Guys, this is Andrew from Cascade Tutoring. In today's video, we're going to talk about linear inequalities in one or two variables as it relates to the SAT. Okay, so let's just go through before we start talking about Desmos, because this is going to be a Desmos heavy section again. Is we want to make sure that we understand what each of the symbols do. Okay, so for example, if I have something like this, that means that reads like this: x is less than something. Okay, so less than means that it is going to be an open circle, meaning that it will never include, right? So for example, x is less than 3, which means that an open circle means that in a graphical sense, if this is a number line, oops, let me just move here. If this is a number line, and this is 3, we know that there is a value of x that is less than 3 but does not include it. So it could be 2.999999999 does not include 3, so therefore that is a true statement. It could be -50. That is a true statement. It could be 2. That is a true statement. It cannot be 3. It cannot be 3 is less than 3. Okay? So if x is greater than 3, again, we're going to do open circle and then everything to the right. Okay. If x is, let me just pick a different number. So we have, if x is less than or equal to 5, this means closed circle and to the left. It can be anything less than, and it also could include that number. Okay. Same thing here, right? I'm just going to go below here. It could include that number and it could go above them. Okay, so when we graph these on Desmos, here's what this looks like. This is going to be a Desmos type of thing. So let's just come up with an example. We'll say y is greater than x. Okay, we will also say y is less than or equal to 2x plus 6. Okay. Whoa, there's a lot going on here. So we have the green and the blue. So we want to know what a solution to the system of inequalities is. So we have two inequalities. What is a solution? Well, there are infinite many solutions. There's a lot of different options. What we're looking for is we're looking for the shaded area. Okay. Now, keep in mind, dotted line, this is like your open circle, does not include. Solid line does include. So what is a solution to the system of inequalities? Any number that lives in this shaded area. So let's go over to 50. So I'm going over to 50, and I'm going to go up to, let's call it 75. So up to 75. That is a point that would satisfy this inequality. It would make it true. If we went over 50 and we went up 40, you can see that's exactly where it touches the dotted line. This would not satisfy the system of inequalities because it is on the dotted line. So again, dotted line means not include, solid line means include. Okay, so there's a little overview here. Let's look at some SAT type questions. Okay, so I'm going to start reading through this. So we bought 2 containers of beads. In the first container, 30% of the beads are red. Okay. Second container, 70% of beads are red. Okay. Together, the containers are 400 beads, or 400 red beads. Which inequality shows a relationship where x and y are the total number of beads for the first container? Okay, cool. So in the first container, we want to convert percentage into decimal. Okay, so remember to do that, we're going to move the decimal over 2 places. So this is going to be 0.30 or just 0.3. And in the second container, we have, converting this would be 0.7y because this is a different container. Now, we know that it is something 400, okay? We did not circle or underline this. This is very important. At least means that it has to be at least, if not bigger than. So I'm going to use the red. So 0.3x plus 0.7y is greater than or equal to 400. So these beads have to be greater than or equal to that to be true. So if that's the case, that is A. B is not true because that reads the opposite. 0.7x plus 0.3y is less than or equal to. This one's dividing, right? And then this one did not convert the percentages. We always want to convert percentages into decimals. Okay. All right. So let's look at this. Cool. A cargo helicopter delivers only 100-pound packages and 120-pound packages. For each delivery trip, the helicopter must carry at least 10 packages, and the total weight of packages can be at most, I'm going to circle this, very important, at most 1,100 pounds. What is the maximum number of 120-pound packages that the helicopter can carry? Okay, cool. So what do we got here? We have two inequalities. So the first inequality, let's look at our helicopter here. So we have 100, let's call it x, plus 120y. Okay, so these two different packages, and that is 1,100. Now, at most, so this is the opposite of the other one, less than or equal to. Okay, it cannot be more than this. It can be equal to this, but it cannot be more than this, so it can be equal or less than. What about the second one? That's in this one here. It says for each delivery trip, the helicopter must carry at least 10 packages. So we have some number of this package, some number of this package, and we have to carry at least this. Okay, so at least again means equal or above. At most means equal or below. Okay, so now that we have this, we want to go into Desmos. So this is where our tool is really helpful. We could go and solve this if we wanted to by hand, but it's going to take a lot less time to do this. Now, making sure that we're really good with our signs because it will make a difference. So 100x plus 120y is less than or equal to 1100. Okay, cool, awesome. So what is the maximum number of 120 pounds per trip? So the maximum in this case, what that means is the number that the maximum number. So this is where they're going to intersect here. Okay. And it says, what is the maximum number of 120-pound packages that the helicopter can carry per trip? So what we're looking for is our y value, because that is our, let's come back here. So where they intersect is 5, 5. I'm looking for the 120-pound packages, so that is 5. Okay, so set up your equation and then use Desmos. Okay, let's do one last one. Okay, so this is a difficulty 2, 1. So which of the following ordered pairs x, y is a solution to the system of inequalities? Now, we could very easily just plug this in, right, and see which one is true. Instead of using Desmos on this, let's just see which one is true. So if we plug in an x1 and our y is 0, let's see which is true. So if 0, is that a true statement? Well, yes, that's a true statement. And then 0 is less than -1. Okay, that is not a true statement, so this cannot be true. Let's plug in the xy coordinates here. So let me do this in a different color. 0 is less than or equal to -1. Well, that's already not true. Let's do this in a different color. So we have 0 is less than or equal to 1. Okay, that's true. And then we have 0 is less than or equal to -1. Well, that's not true. Let's check to see if this is true. Sometimes kids will just pick the last answer and they've made a mistake, so we always want to verify. So we have 0, or sorry, we have -1 is less than or equal to 0. True. -1 is less than or equal to -0. Well, -0 is the same thing as just saying 0, and that is a true statement, so that's true. Had we gone into Desmos, and graph these, what we're looking for is the overlap part. Only one of these points will overlap in the shading. So we'll have something like this. The shading would be this part here. That's what we're looking for.